Alright, so this video is going to be part 3 of our practice with finding equations for lines in 3 dimensions. Okay, now our problem is up on the board. We need to find all 3 types of equations for the line that passes through the points 2, 4, negative 3, and 3, negative 1, 1. Okay, so we did a problem like this where we had to find all 3 types of the equations for a line in the part 1 video. Okay, so if you feel pretty comfortable with it, I'd really recommend that you try this problem. Okay, try this problem on your own, and then if you get stuck, well, I'm going to be going over it anyway, so it's no big deal. Okay, so anyways, let's start off. We need, what do we need for the equation of a line? Well, we need a point. Okay, we need a point. We have 2 points here, and we need the direction of the line. Okay, so we need a vector that represents the direction of the line, and well, we don't have that here, but we have, this line passes through these 2 points. So we can actually just find the direction by, doing this minus this. Okay, and that'll give us a vector that goes from this 2, 4, negative 3 to 3, negative 1, 1. Okay, so first off, we're going to write these points as position vectors. Okay, we're going to write this as 3, negative 1, 1, and we're going to subtract 2, 4, negative 3. Okay, let's do that. 3 minus 2 is 1. Negative 1 minus 4 is negative 5. And 1 minus negative 3 is 4. Alright, so now we have our direction, okay? So we have a point, we'll use 2, 4, negative 3, and we have our direction 1, negative 5, 4. Okay, so we can plug that in with our vector equation. Remember, I'm going to write this again. Our equation in 2D is y equals b plus mx, and our equation in 3D is the vector r equals the vector r naught plus tv. Okay, so you can see, when we plug in our initial point, we get b in 2 dimensions, and our initial point, the point that we know, is going to be r naught in our 3D equation. Okay, so the comparison is there, and for our slope in 2D, that's m, right? That's our direction of the line, and our direction of the line in 3D is vector v. Okay, so we just got to plug these things in. If we plug these things in, we get our vector equation. That's r equals r naught. That is our point that we know, 2, 4, negative 3. We're going to add the parameter t to our vector that gives us direction 1, negative 5, 4. Okay, this right here is our completed vector equation. Okay, so you can even write here vector equation. Now next, we need to find the parametric equations. Okay, that's the next step. And how do we do that? Well, we can actually just start computing these vectors out to make it a singular vector. Okay, so first off, we know that r is x, y, z. Okay, just some point that's on our line. And well, we do a little bit of scalar multiplication here, multiplying this t through our direction vector to give us plus t, comma negative 5t, comma 4t. Then we're going to add these vectors together. So we get that the vector x, y, z is equal to, well, we're going to have a 2 plus t, okay? Because we have to add these vectors, we get 2 plus t. That's just adding our x components. We get comma 4 minus 5t. And then we have comma negative 3 plus 4t. Okay, now our x component on this side needs to equal our x component on this side, and so on and so forth with our y's and our z's. So we get our parametric equations. X equals 2 plus t, y equals 4 minus 5t, and z equals -3 plus 4t. And lastly, if we solve each one of these equations for t, and then now set all these things equal to each other, we get our symmetric equations. So first we have that x equals 2 plus t, and we can subtract 2 on each side to get that t equals x minus 2. Okay? Now, with our y equation, we have y equals 4 minus 5t. We subtract 4 on both sides to get that y minus 4 is equal to -5t. We divide by -5, and we get that, well, t is going to equal -y plus 4 divided by 5. Okay? And then lastly, let's do z. Z is equal to -3 plus 4t. Okay? We add 3 on both sides. Okay, we add 3 on both sides. Z plus 3 is equal to 4t. We divide by 4, and we get that z plus 3 over 4 is equal to t. And now we can set all these things equal to each other. Okay? We get that x minus 2 equals -y plus 4 over 5. And that's going to equal z plus 3 over 4. Okay? That is the symmetric equations. Now, if we had to find the point on this line that is on the xz plane, okay, let's say we had to do that. Okay, that was something else that was attached to this problem. Well, on the xz plane, y is 0. So now, if you plug in a 0 for y, you get 4 over 5. And of course, now you can easily find x and z, because x minus 2 is going to be equal to 4 over 5 is going to be equal to z plus 3 over 4. And you can find what x and z are. And there you go, you have your point. And you don't need to worry about solving for a parameter and then plugging it back in like we did in the part 2 video, okay? So, my point being, if you're given an extra problem like that on top of this one, and you've already found all 3 equations, I think that using the symmetric equations would be the way to go. Okay, because then you don't have to worry about your parameter at all, which is both present in the vector equation and the parametric equations. Okay, so anyways, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for equations of lines in 3 dimensions, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.